18 hours. That is all the time between a tropical storm and a Category 5 hurricane sitting directly over the Gulf of Mexico. Not days, not weeks, 18 hours. Most evacuation plans require 72 hours to work. The road network closes approximately 12 hours before landfall. That gap is not a planning failure. It is a physics problem. And right now, the Gulf of Mexico is running the exact conditions that make that physics problem as dangerous as it has ever been in recorded history. By the end of this video, you're going to understand exactly why the Gulf is different from every other hurricane basin on Earth right now. You are going to understand the specific ocean structure beneath the surface that removes the natural brake on storm intensification, the one thing that normally slows a hurricane down before it hits land. You're going to understand why the evacuation system that millions of people on the Gulf Coast depend on was designed around a warning window that rapid intensification can collapse entirely. And you're going to understand something that almost no mainstream hurricane coverage explains clearly. Why the storms that kill the most people are not always the ones that are Category 5 for the longest. They are the ones that become Category 5 at the worst possible moment. Stay with this past the 4-minute mark, because what comes next is the piece that makes everything else make sense. Start with what the Gulf of Mexico actually is right now, not what it normally is, what it is in May of 2026. Sea surface temperatures are running approximately 2 degrees Fahrenheit above average. That number sounds small. It is not small. 2 degrees Fahrenheit across an entire ocean basin represents an enormous amount of stored thermal energy. Energy that a hurricane will consume and convert into wind, rain, and storm surge the moment it crosses that water. Brian McNulty at the University of Miami's Upper Ocean Dynamics Lab has confirmed ocean heat content at near record levels as of this month. But sea surface temperature is only part of the story, and it is not even the most important part. The most important part is what is happening below the surface, specifically what is happening inside a structure called the loop current. The loop current is a river of warm water flowing through the Gulf of Mexico, 200 to 300 kilometers wide, 800 meters deep. It is not a surface feature. It is a column of warm water extending hundreds of meters below everything a satellite can measure. And right now, the loop current is positioned directly beneath the projected path of the developing tropical system in the Gulf. Here's why that matters more than almost any other single factor in hurricane intensification. When a hurricane moves over warm water, it does something that acts as its own brake. The storm's circulation churns the ocean below it. It drags cold water up from depth. That cold water replaces the warm surface water. The sea surface cools. The hurricane loses fuel. This is the ocean's natural self-correcting mechanism. Warm water drives intensification. The storm stirs up cold water. Intensification slows. It is a feedback loop that has moderated countless Gulf storms throughout history. But the loop current breaks that feedback loop completely, because when the warm water extends 800 meters deep, there is no cold water to bring up. The storm's upwelling pulls more warm water from below. The natural brake disappears. We know exactly what happens when a hurricane crosses the loop current. We have watched it happen in real time. We have the data, and the data is not reassuring. Hurricane Katrina crossed the loop current in 2005. She went from a Category 2 to a Category 5 in less than 9 hours. 9 hours. Hurricane Ida crossed the loop current in 2021. Ida went from a Category 2 to a Category 4 in 12 hours, making landfall at peak intensity directly over southeastern Louisiana. Hurricane Helene crossed favorable warm water in 2024 and delivered catastrophic inland flooding across the southeastern United States. And then there is Milton. Hurricane Milton, in October 2024, went from 80 miles per hour to 175 miles per hour in 24 hours. That is the fastest intensification ever recorded in the Atlantic Basin. NASA confirmed that Milton became the fastest storm in Atlantic history to go from a tropical depression to a Category 5 hurricane. The loop current was a primary driver. These are not anomalies. They are not once-in-a-generation flukes. According to the data, 80% of major landfalling Gulf hurricanes undergo at least one period of rapid intensification. 80%. That means a major Gulf hurricane that does not rapidly intensify at some point in its life cycle is the exception, not the rule. Rapid intensification is defined as a wind speed increase of at least 35 miles per hour in 24 hours. That is the official threshold. But the storms that change history do not stop at the threshold. The storms that change history do what Milton did, what Katrina did, what Ida did. They cross the loop current and they do not slow down. Here is the number that closes this loop and sets up everything that comes next. Atlantic tropical cyclones are now 29% more likely to rapidly intensify compared to the period from 1971 to 1990. 29% more likely, not marginally more, 29%. That is a structural shift in the baseline behavior of Gulf hurricanes happening in real time across decades of data. And that shift is colliding directly with an evacuation architecture that was built around a different baseline. Here is what the Gulf Coast evacuation system actually requires to function, not what the press releases say, what the physics and the infrastructure actually demand. From the moment a mandatory evacuation order is issued, it takes approximately 72 hours to move the population that needs to move. 72 hours for the road network to process the volume of people leaving coastal zones. 72 hours before the interstate's thin enough that the last vehicles can clear before conditions deteriorate. The road network itself closes to safe use approximately 12 hours before landfall. That is when winds and rain make highway driving genuinely dangerous for most vehicles. That is the hard stop. So the system requires that evacuation orders go out roughly 72 hours before landfall, which means the forecast needs to be accurate enough, specific enough, and dangerous enough to justify a mandatory order at the 72-hour mark. Now apply rapid intensification to that timeline. A storm that is a Category 2 at the 72-hour mark does not automatically trigger a mandatory evacuation in every jurisdiction. A Category 2 is serious. It is not always catastrophic for well-constructed structures further from the immediate coast. Local officials weigh economic disruption. They weigh the cost of a false alarm and the erosion of public trust that follows. They weigh the storm's track uncertainty. And often, a Category 2 at 72 hours does not produce the mandatory evacuation order that a Category 4 or 5 would. Then, rapid intensification happens. 18 hours before landfall, the storm crosses the loop current. The Category 2 becomes a Category 5, and the 72-hour window has become an 18-hour window. 18 hours is not enough. The interstates are full. The gas stations are out of fuel. The contraflow system, which reverses inbound lanes to outbound to double evacuation capacity, takes time to implement, time that no longer exists. And here is the detail that most coverage misses entirely. The thing that should make you stop and reread this section. Storm surge, not wind, is the leading cause of hurricane fatalities, not the roof being torn off, not the windows imploding, the water. A 20-foot storm surge submerges a 2-story house completely, not partially, completely. Every floor, the roof, gone. 67% of Gulf Coast interstates flood in a 23-foot surge scenario. The roads you need to evacuate on are underwater. The cars that waited too long are underwater. The people who did not leave are in attics, waiting for rescue that cannot reach them because the rescue routes are underwater. This is the cascading failure that rapid intensification produces. Not just a stronger storm. A stronger storm after the window for an effective response has already closed. Let's step back from the immediate event and look at something that reframes the entire picture, something that storm track coverage never has time to explain. The Gulf of Mexico is not just warmer at the surface. The entire column of water is warmer than historical averages. And the loop current is not a new feature. It has always been there. But its position, its depth, and its interaction with developing storms is becoming more consequential as ocean heat content rises. 70% of billion-dollar landfalling hurricane events in the United States involved rapid intensification. Not 50%, not 60%, 70%. That is the signature of how catastrophic economic and human loss from Gulf hurricanes actually happens. The damage is not spread evenly across slow intensifying Category 2 landfalls. It is concentrated in the events that transformed late, intensified quickly, and arrived before the response system could adapt. The infrastructure was not designed for this version of the Gulf. The evacuation timelines were established when rapid intensification was less frequent, and the ocean heat content driving it was lower. The National Hurricane Center issues its forecasts every 6 hours. Rapid intensification can happen entirely within a single 6-hour forecast cycle and still surprise the models. Not because the models are bad, because the ocean dynamics that drive rapid intensification operate on spatial scales smaller than the models can fully resolve. The loop current itself is a known feature. Its position is monitored. But the exact interaction between a specific storm's circulation and the exact thermal structure beneath its path on any given day involves a level of complexity that produces real forecast uncertainty, even with the best available tools. What this means practically is that the forecast confidence interval around intensity widens significantly in the 24 to 48 hours before landfall for Gulf storms over the loop current. The same window that the evacuation system needs to be most accurate is the window where the physics is hardest to pin down. Now close every loop this video opened. Start with the ocean. The Gulf of Mexico is running 2 degrees Fahrenheit above average sea surface temperatures, with near-record ocean heat content confirmed by researchers at the University of Miami. The loop current, 200 to 300 kilometers wide and 800 meters deep, is positioned directly beneath the projected storm path. When this storm crosses that structure, the ocean's natural brake on intensification disappears. The historical record is not ambiguous about what happens next. Katrina, Ida, Helene, Milton. These are not edge cases. They are demonstrations of the same physical process running on the same Gulf geography. The evacuation system requires 72 hours. Rapid intensification can compress the usable warning window to 18. The gap between what the system needs and what the physics allows is not closable through better communication alone. You cannot communicate your way around the loop current. You cannot issue a press release that makes storm surge physics less lethal. The road network floods when it floods regardless of what the alert system says. The only variable the individual can control is the decision timeline. The decision to leave must happen earlier than feels necessary, earlier than the official mandatory order in some cases, earlier than the Category 2 forecast seems to warrant. Because the 29% increase in rapid intensification likelihood is a population-level statistic. For any individual storm, the question is binary. Either it rapidly intensifies or it does not. And the time to make the wrong assumption is not when the storm is 18 hours from landfall and you're sitting in stopped traffic on a flooded interstate. The 70% figure on billion-dollar events is the clearest statement of how Gulf Coast hurricane risk is actually distributed. The catastrophic events are the ones that transformed late. That is where the fatalities cluster. That is where the economic damage concentrates. Here is the sentence that closes every loop opened in this video. The storm is not the worst-case scenario. The worst-case scenario is a storm that sits at Category 2 long enough to delay evacuation orders, crosses the loop current 18 hours from landfall, and becomes a Category 5 after the road network can no longer safely process the volume of people trying to leave. We have watched that scenario play out. We have the satellite data. We have the post-storm mortality analysis. We know exactly what it looks like and exactly what it costs. The Gulf of Mexico is carrying more heat than it has carried in the historical record. The loop current is in position. The storm is developing. The physics does not negotiate. What changes the outcome is not better technology or better forecasting alone. What changes the outcome is understanding before the storm is named, before the track is certain, before the mandatory order arrives, that the window for a safe decision is always shorter than it appears. If this video changed the way you think about Gulf Coast hurricane risk, not as a weather story, but as a systems problem with a physics constraint that the evacuation architecture cannot override, share it. The people who need to understand the 18-hour window are not only the ones already watching storm track channels, they are the ones who do not yet know that the Category 2 on the map and the Category 5 making landfall can be the same storm. Subscribe if you want to understand the next event before the headlines tell you it already happened.